Okay, hello everybody. We're going to continue where we left off on the Q meter. Make sure my camera was in frame there. This is a circuit we're going to be doing tonight. This is the buffer amplifier. In the last video we put together the oscillator and got it running between an output of 80 to 40 meters. So it was running good. Now this is going to be just an amplifier for that, so that anything we attach at the output doesn't bother the oscillator or shift the frequency. Now what this is, just really quick here, this, from the last video and this video, this is essentially what we're putting together. This is what was in the last video. And this is the rest of it we're going to build this time. We won't be using a voltage regulator. There won't be any need for it, since I'm only going to be using this to check coils. If we're going to use it for a VFO or a local oscillator and a shortwave receiver, we would need a voltage regulator, so at any changes in line voltage, it wouldn't make your station drift off. It would hold the oscillator frequency at 1, because the oscillator is subject to change with changes in voltage that'll cause it to shift frequency. Okay, the circuit comes from a T195 GRC19 military transmitter. This page is, if you find these online, there should be a PDF, look up if you want, for the T195 manual. The T195 is the nomenclature, the model of the transmitter, and this little circuit that we're using is right on page 42 out of that manual. The voltage regulator in here, they use the voltage regulator on this one, and in the transmitter they're actually using the screen grid, or the suppressor grid, to key the oscillator with. I'll talk about that in another video. This very same circuit with this schematic, if you can see this a little better maybe, we apply 45 volts minus through a shaping network, and your key, CW key, would plug in right here from between here and ground, and you ground. It takes away the negative 45 volts and allows this tube to output. That way you're not stopping and starting the oscillator, and it keeps you from what they call chirp every time the oscillator starts up. So it makes a real clean CW signal. And I'll go over this in another video, specifically for a keyed VFO. Okay, another look at the schematic before we start. From the last video, this C5 is already in place. It's already hooked to pin 1. So we're going to start right with the resistor and continue on. So here we are. Get my little parts bin out here and dump them out. Okay, R4 is 56k ohm resistor, goes from pin 1 of V2 to ground. I don't have a half watt resistor. I found a 1 watt. It doesn't have to be a 1 watt, it's just what I happen to have. And we're going to hook that to pin 1 where the cap's hooked. Going to go to ground with it. I can snake that in there. And that's good enough. Okay, that resistor's in. Next on the list, and this is where I messed up on the last one, if you've seen that video, I forgot to hook pin 2 of V1 to ground. So here we're going to hook pin 2 and pin 7 of V2 to ground. Okay, here's pin 1. Just going to stick that wire in there like that. Give it a little bit of a bend. See if I can get all things going here at the same time. There we go. Okay. I'll solder that into the tube. Okay, that was pin 2 to ground. Now we got to do the same thing to pin 7 right there. Alright, and I'm not wrapping these around the pins because I may want to disassemble this, and I'm just going to make it easy for me to take it apart. If you were doing it and you knew you wanted to leave it permanent, you could go ahead and wrap that around there and make a tight fit. But it'll work just as good, just to solder it. Make sure the solder is not a cold solder joint. Use plenty of solder so you get rosin on there. Give it time to flow. There it is. Alright. Now, next, what do we got? Okay, C6. Well, what do we have here? Oh, from there to ground. I didn't type it in right. From V2 to ground. My bad, I was in a hurry typing, I didn't get that. So C6, what we're looking at here. Find the schematic, see what we're talking about. Okay, here's C6, goes from pin 6 to ground. It's a .01 cap. From pin 6 to ground. .01. And here's pin 7, so pin 6 right there. Okay, now we got a resistor that has to go in there. We just put that in, so now we're looking for R5, the 33K. R5, 33K from pin 6 to the B plus point at C810. Now, I don't show that in the schematic. C810 is over here on the side. It's my tie point, and this is where when I hook a power supply to this, I just tie in right here. So we're going to go from that spot we just put the cap over to there with this resistor. It's already got a nice long lead on it. We're just going to lean it, hook it in there. Lean it over there, like so. Oh, wait a minute. Wrong one. Getting in a hurry here. Do something look right. Didn't look right. Didn't look right. All right. There we go. That's better. Now this was 2 resistors in series. We needed 33K, so I'm using a 27K and a 3.9K, and hooked them together with the ohm meter. With the tolerances 20%. It'd give us right at 32.8K. Even though the numbers don't agree, that's what the ohm meter says. Just under 33K. And this circuit isn't that critical. You could get away with anything from 31, 32K to 36, 38K. It wouldn't keep it from working. Pretty forgiving circuit. This is why I like to use it, because you just put it together. As long as it's wired correctly, it will work. You don't have to do any troubleshooting. Just hook it up, give it filament voltage, and the thing will just take off and work. Tail of that's a little too long, so I'm going to trim it. I don't want it touching our other pin there. Okay, so that's pin 7 and pin 6. And next on the list is pin 6. That's the resistor I tried to put in there. The 10K 2 watt from pin 5 of V2 to the B plus point. So now that resistor that was wrong a minute ago, I'm going to take that and put, this is why it didn't fit. Okay, from there to that same point, stay put long enough for me to solder it. Okay, now we got one more thing we have to tie in there. Look at the schematic again. What we just did is we tied our 10K to pin 5, and we got the 33K to pin 6. We tied it to the B plus point, 10K up here to the B plus point. Now we got C7, a 20 picofarad cap right here. We're only going to hook up one end because this is just going to be the signal output port point for our next circuit. Coming up in the next videos, it's going to get a little more complicated. We're going to step up the work here. Now, this point right here is where that cap's going to come in. It goes into our coil that we're going to test. There'll be a sample over to a set of diodes, and what that's going to do, it's going to detect resonance. When this coil is at resonance, this voltage is going to come up. The voltage sample is going to get stronger. It'll be rectified by the diodes. The little potentiometer here is a gain pot, so that if we got a meter in this circuit, and what we do is if it's too much, we turn the gain down to keep the meter in the scale, and that'll show our resonance. It's not really anything that tunes it, it's just kind of a calibration thing, so that we give just enough signal to the tube to make the meter deflect at least halfway, something like that. But this is a circuit we're headed. This is be coming up in the next couple of videos. And this is actually the active part of the circuit. We needed a signal to inject here. That's what we've been doing, is building the amplifier and the oscillator so that we have a signal to put in here. Needs 3 or 4 volts of RF to feed to this cap to excite that coil that we're going to test. Okay, so now we'll put this cap in there, and that ties to the plate, or pin 5 of V2. I'm just going to lean this over there to get it out of my way while I solder it. Well, it's going to argue with me. That's okay. Pull it back up in place here. There we go. And let's see. I believe we got all the pins nailed down. All the parts hooked. So our next, the circuit I just showed you, is going to add parts to this tube, V3. Right there. That's where that's all going to go. And that's basically our kind of our voltmeter. We're just using that tube for a voltmeter. Okay, in the next video I'll test this out, and I gotta come up with a little RF probe so I can measure the voltage here before we get that circuit going, so we can see if this tube is actually working. I don't have any doubts that it will, but in case there's a problem, why, I can troubleshoot it before we get on into the building the rest of the circuit. Okay, if you need, if you like any of these schematics, they're all in JPEG form. and they're small, shoot me an email and ask me for the Q meter schematics. The Q meter schematics for the receiver coil tester. Okay, thank you guys for watching. If you think this video is doing you any good and you want to follow along, this is something you want to build and you want to see the next videos, why, please subscribe and hit the notification bell, and you'll be notified to know the next video I put out. Thank you for watching, and see you on the next video.